All right, good morning. All right, so now 3.1, calculus 1. All right, so we have derivative of y equals a to the x, where a is going to be greater than 0 and a cannot equal 1. Okay, because 1 to any power is going to be 1, right? Yes? Yeah. Okay, all right, is everyone following along? Yes. Okay, so, yeah. So 1 to any power is going to be just 1. All right, so we're going to take the derivative of this. So the derivative, if I'm doing this here, it's going to come out to be this. So the derivative of a to the x is going to be a to the x ln a. Okay, and where a could be whatever value. All right? All right, so let's do this one here. So, what is my a value in this one? 2, right? The a value is 2. Okay, good. So let's take a look. So I'm going to rewrite this. So it's going to be equal. So this is going to be 2 to the x ln of 2. That's it. Yes? All right, now, in this one right here, it's going to give me some slight issue on this one. Okay, what is that issue? It's negative, right? Okay, so now to make it positive, what would I do to make that positive?
Just rewrite it.
Rewrite it, how?
1 over 3.
Very good, so it's going to be rewritten as 1 over 3 to the positive x right here, right?
Yeah.
Now, what rule is that going to be?
It's that one which is...
It's a fraction.
Yeah.
We could also call fractions what? Quotient rule. Very good. When we divide it, right, it's going to be a quotient rule. So derivative of the first one is going to be, so it's going to be 0, right, because that's a constant, times g of x, which is 3 to the x minus, right, and derivative of this, so it's going to be 1 times 3 to the x ln of 3 all over 3 to the x squared, right? Yes? Mm-hmm. Okay, so now I could actually clean this up. Anything times 0? 0. So that's going to give me 0, so it's minus this. So it's negative 3 to the x ln of 3 over 3 to the 2x, right? 3 to the 2x. Now, can I cancel out one of those? Say yes. I can cancel out one of those, can I? So if I can cancel out one of those, what's going to happen to on top? That 3 to the x goes away, right? So it's going to be left with negative ln of 3 over 3 to the x. All right, you guys, I remember that there was some tricky thing on this one right here.
Oh, it's like the equivalent, or like first we find the derivative of x squared plus 1.
Yeah, so now, because I could break this up into different things, and I'm going to use, I'm going to use a lot of scratch paper on this one. So I just wanted to get to that first. Yeah, so, all right, 1/2 to this. Was it x squared plus 1? All right, so a couple algebra rules out of this, okay? This plus sign right here means what? Okay, let's try this. X 3x, no, let me just go 3. I'm not going to make it too complicated. X to the 3 times x to the 4. What do I get there? X to the what? A. I hate to like try to get you guys to pay attention because this is important. Okay. What do you get here? X to the 7, right? How'd you get x to the 7? So it's going to be like this. It's x to the 3 plus 4, right? Which is going to give me x to the 7, isn't it? So can I take this information right here and break that up there? Say yes. Okay, I'm going to. That's what I need to do there. That's what I need to do. So I am going to get rid of that using that rule because I need to change this up. So let's take a look. It's going to be 1/2 to the x squared, right? And then it's going to be times 1/2, right? Okay, what rule is that now? Product. It's product. It's being multiplication, right? But because there is no variable here, this thing is going to just be treated like a constant. Okay? So that thing's going to be treated like a constant. So now I'm going to take the derivative of this right here. Okay? But before I do that, I'm going to break this up. Because if this is going to be, think of it like this. So 3 to the 4 squared. What would I do to each of those values? Square each one. So that would be 9 over 16, right? Because I square each item on there, right? I could do the same thing, the same rule, but with this up here. Okay, I'm going to use the same rule there. So let's go ahead and do that. So just because it's variables doesn't mean that I can't change it up. All right, so this is going to be 1 to the x squared over 2 to the x squared, right? Yes? And that still times my 1/2. Okay? Anything, so 1 to any power, no matter what it is going to be what? 1. So this right here is just going to be 1. That's the reason why we had that rule at the beginning where the a value could not be 1, because 1 to any power is just going to give me 1. So right here, this is going to turn into, so I'm still rewriting it so I could still do the problem. I'm setting it up right now. 1 over 2 to the x squared, right? Now it's to a point where I could actually do this. Okay, now it's to a point where I could actually do this. So because of this, I could actually do this here now. So with this is actually going to be the quotient again. This is a quotient again. So now it would be, if I'm multiplying, it's 1 times 1, which is just going to give me 1, right? And then there's 2 times this piece out here on the bottom. So, no, it's not going to be 4 because that's 2 to some power. So it's going to be 2 times 2 to some other power. So it's going to be different than this. It's not the same 2 because this is the base of some exponential. So I can't just multiply those and call that to that exponential. It's not going to be the same. All right, so now I'm going to do the quotient rule like I did before. Derivative of the top is going to be 0 times all of that, which is going to be the bottom, which is 2 times 2x squared. Minus. So now it's going to be a minus sign. So now it's going to be 1, because that's going to be on the top, right? 1, so it's going to be 1 times anything is just going to give me that thing right there, right? So now I need to actually do the derivative of this. So doing the derivative of this, I know that this is going to be chain rule here. Okay? Because this is an x squared, it's going to be a chain rule. So what's the derivative of x squared? 2x, right? So it's going to be 2x times the derivative of this now. So 2 to the variable. So 2 to the variable right here is going to give me, remember, it's going to be 2 to the x squared ln of 2, because 2 is my base, right? Did I lose anyone? Please speak up. We got a small class here today, so if you're having trouble with this, please say something. Are you okay? No. Okay. Okay. What are you not happy with? The whole thing. Okay. Oh, I need some specifics. You can't just say all of that in red. So, did you understand how I broke this to this? Okay, you're okay with that. Are you okay that I changed this like this? Okay, because I took the power to the top and bottom, right? Okay, are you okay that I changed this to just 1? Because 1 to any power is still just going to be 1, right? So that, are you okay down to here? Oh, this part down here? Okay, so now, on the top, it's going to be 1 times 1, right? So it's the top of this. So my top is going to be, so if we call this F and this in G, so F prime is 0, G prime is all of this. Okay, so what am I still missing on this one here? I'm still missing that 2 out there, right?
Maybe you should show us how you got the equation, 2x times 2x squared ln 2.
This right here? All this?
Yeah, I think that's where we're confused.
Okay, so let's do this again then. Okay, so it's going to be 2 times 2x squared, right? So because this is an x squared right here, that's an x squared. That's going to be a chain rule. Okay, so now let's pretend like it's a chain rule, all right? Because it is. So I'm going to say that u is equal to x squared. What's the, okay, so now, what's the derivative of that? 2x, right? So it's going to be 2x. So I have the derivative of this, right? So 2x, so it's going to be 2x times, and that 2 is a constant, so it's just going to stay out front here. The 2 is a constant, it's going to stay out front, okay? So now, are you okay with that part? Is everyone okay with just derivative of x squared, right? Okay, so that took care of that. Now, I'm going to just now treat this right here as it's 2 to the u. Okay? I already took care of the derivative of that. I just took care of that, all right? So I don't have to deal with that part anymore. It's just going to be 2 to the u. Are we okay? Yes? Are you still okay? Better? Okay, so what's going to happen now? So this 2 to the u is going to turn into, what was the rule for this one? What's the derivative of this? What's the derivative of this? Right here, look. Derivative of this is going to give me this. Okay? Now let's go back to this. So the derivative of this right here. To what? ln of 2. Yeah, that's it. Right? So now let's put back my u, so it's not so confusing anymore, right? So remember we said u is this, right? Okay, so let's replace that. So I'm going to do some multiplication anyway. So 2 times 2, and this is going to be 4x 2 to the x squared ln of 2.
So like what happened to the one? You know how it's 1/2? What happened to the one?
Okay, I'm just getting this right here. I'm just still getting the g. I still haven't finished my problem. I'm just trying to get this part right here. You guys said that, you know, I stopped to do this one because you're like, oh, hey, that's where I'm messing up. Are we okay here now? All right, so we have this piece right here is the derivative of the bottom. So I'm erasing because I'm going to finish up this now. Okay, so now I'm doing the quotient still, right? So it's going to be the derivative of g times f. Anything times 1 is just going to be that number, right? So g prime, so we said 4x times 2 to the x squared ln of 2 all over the quotient rule. What's it going to be for the quotient rule? So it's going to be 2 times 2x squared squared. Now, anything times 0. 0. So all this goes away, right? All this goes away. So now I'm going to be negative 4x, and it's going to be 2 to the x squared ln of 2 over. Now I'm gonna expand this. I'm gonna actually like multiply this in. So what's 2 to the 2 to the second? 4. So I have 4, and then it's going to be right here. What's going to happen to this right here? So if I square this, it's going to become 2 to the 2x squared. Questions before I do the algebra part? Is there any questions? Are we okay? Is everyone, because I slow down, back it up, and now we're getting to the part where I'm going to clean it up. Okay, is everyone okay with what I did on the bottom? Yes? Okay, is there a minus sign in the top, or the minus anymore? This is no longer a binomial, is it? Because all this became 0, I'm going to have a monomial over a monomial. So that means that I could just reduce this. I could cancel out from here now. So, what can I do to those 4s? Can I cancel those 4s? Yes, I can cancel the 4s. Okay, I have 2 to the x squared here, and down here I have 2 to the 2x squareds here. What can I do with that information? I could cancel out one of them, right? I'm going to cancel out one of them because this down here I have 2 of them, but right here I only have 1. So this goes away, and that goes away. So what is left on top? Negative x ln of 2 over 2 to the x squared. Okay. Well, we ended up using quotient rule again for this. And we had some chain. This is a little bit of everything here. Alright, so let's take a look. Go back to the thing. Alright, so power rule for the functions. Alright, so now same thing. What's the derivative of the inside here? Negative 3x squared. Okay? Times. Now, if you treat all of this, because I already took care of that, as u to the negative 5, right? What's the derivative of that? Okay, so it's going to be negative 5u to the negative 6, right? Yes? What did we say u was? 3 minus x cubed, right? So let's split that back. So it's going to be negative 3x squared times negative 5. Come on, board work. Negative 5. And that's going to be 3 minus x cubed raised to the negative 6. Okay, so I can do a little cleaning up, right? So it's going to give me a positive 15. Positive, come on now, 15x squared times 3 minus x to the third to the negative 6th. Are we okay? Question? If you have questions, please speak up. Please, please, please. All right, so let's take a look at the bottom. Okay, so now, what would I consider a u on this one? What would be the u here? Cosine, right? So I'm going to say that cosine, right? So it's going to be u to the third, right? Right, yes? Okay, so it's going to be, take the derivative of that, right? What's the derivative of that?
3u.
Okay, so that's going to give me 3u squared times.
Negative.
Now, what's the derivative of cosine? Negative sine, right? So it's going to be times negative sine of theta. Okay, put the u back, right? Put the u back. So it's going to give me 3 cosine squared theta times negative sine theta. So take care of the negatives, right? So it's going to give me a negative 3 cosine squared theta sine theta. Is it easier to do this when we consider our outside part, the u? Is that easier? Maybe? Okay, so this is product and chain together. Product and chain together. E to the x times that quantity, that's going to be a product. So we're going to call this one F, call this one G. So F prime is what? E to the x. G prime is?
3x squared plus 1 to the square.
Okay, so it's 3x squared plus 1 to the squared
By 2x.
by 2x. Is there an okay on that one? Does there anyone want me to actually go over that part again? Yes, no, maybe? Yes? Are you okay with that? Okay. Alright, so we could fix that a little bit. Wouldn't that just become 6x? Yes? Okay, that would be 6x and times quantity of that. So I'm gonna, when I plug it in, I'm gonna plug it in as 6x. Alright, so product rule. So the derivative of f, so it's f prime g, so it's gonna be e to the x times g, which is this, x squared plus 1 to the third, okay, plus sign, and then it's going to be g prime f, right? G prime f is going to give me 6x quantity x squared plus 1 squared, right? So there's that. There's my g prime times the f, and the f is just e to the x. Okay? The only thing that you could do with this mess is actually factor out those e to the x. Okay? Unless you feel like expanding the cube or expanding the square and doing all the distribution that goes along with this. You don't have to though. So the only thing that you would do is going to say e to the x, and it's going to be x squared plus 1 to the third plus 6x quantity x squared plus 1 squared. Like that. That's the only thing that you would do is take the e to the x out.
What is it called? Cleveland.
No, I couldn't get it to work. I have the like the original PowerPoint and I still couldn't get it to work. Alright, how many more of these do we have? Is this the last one? Nope. Alright. So I'm gonna run out of time, so I guess we'll finish it tomorrow.
Wait, we've got 10 minutes.
I know we have 10 minutes, but I want to give you guys time to work on some of this stuff before you forget what we're doing.